This is a practice assessment on basic geometric shapes. We're going to have a look at part A here. Make sure you've tried this first before you watch this tutorial. We've got a triangle 0, 5, 4, 8, 6, 0. The best thing would be to do is to draw that triangle. So you whip it up, put those points in, label them A, B, C. You've got 0, 5, 4, 8, 6, 0. You're asked to investigate the properties of the triangle and find the midpoints. So investigate the properties. We look at the distances between the points, we look at the midpoints, we're going to look at the gradients, and we'll find the equations of the line. Those will be the properties of the triangle. So here we go. The distance formula, you should be familiar with that. The length of x and the length of y, you square it. This is Pythagoras theory, and you find the square root. So from A to B, we find that the distance is 5, putting in the points there. Then we look at B to C, A to C. They're all in units, they're not meters or centimeters, so there we've found the distances. Are any the same? No, so it's not isosceles or equilateral. Then we're going to have a look at the midpoints. There's your midpoint formula. You add your x values and halve them, add your y values and halve them. So the midpoint of AB is going to be the point 2 and 6.5. Do the same for the midpoint of the next one and AC. Then write them in. P, Q and R, those are the midpoints. 2, 6.5, 5, 4, 3 and 2.5. If I've gone too fast, stop, work out the midpoints yourself. Then we're looking at the gradients. Change in y over change in x. So the gradient of AB will be 8 minus 5 over 4 minus 0, which is 3/4. Work out the gradients of the other two. BC is a negative gradient, you go down 4 along 1. And the gradient of AC is negative 5, 6. Are any of these gradients the same? Anything parallel, or do they multiply to negative 1? Are they perpendicular? So we've got to check that to see if any of them multiply to negative 1, and you'll find no, none of them multiply to negative 1. So let's have a look at the equations of the line. The equation of line AB is y equals mx plus c. So you put the gradient in first and use one of the points. So that we're going to use the point 0, 5. It lies on that line. So you plot those in and you see that c equals 5, and so you can write the equation y equals 3/4 x plus 5. Do the same for the other 2 points for BC and put the point 6, 0 in there, and you'll find that c equals 24, and do the same for line AC. So now we have the 3 equations of the line. Triangle ABC is therefore a scaling, non-right-angled triangle. There are no right angles there, there were none of them were perpendicular, and so we know it's a scaling. That means all 3 sides are different. Now we're going to look at part B. Join the points P, Q and R, those are the midpoints, and shade in the quadrilateral. Investigate the properties of the quadrilateral. So go back to your drawing, draw in the midpoints, there they are, shade them in, and you're going to investigate the properties. You're going to see their parallel sides. They look pretty parallel, but we've got to check it with the gradients or the distances. So does the gradient of PB equal the gradient of RQ? So let's check out the gradient also of PR. Does it equal the gradient of MB? Is the length RQ equal to PB? And what about the length PR? Is that equal to QB? Do the diagonals meet at 90 degrees? Is BR perpendicular to PQ? Those are the diagonals. So we'll investigate all those things. And first of all, we'll have a look at the gradients. The gradient of RQ is 0.75. And we know that it's the same as PB, which we worked out before. Look at the gradient of PR. That's negative 4. It's the same with BQ, so we know that we have a parallelogram. PBQR is a parallelogram, and you've got the gradients of the other two, BR and PQ. Sorry, this parallelogram. Gradient of BR, hold on. Yeah, these are the diagonals, so we're checking the diagonals. Do they multiply to negative 1? No, they don't, so therefore they are not perpendicular. And there we've finished and investigated that parallelogram.